everyone! Look at what I have here. So this is a clock that I modified so that it goes backwards and it has only a second hand. Why am I excited about this? Well, I can use this to represent an electron. So electrons can have a clockwise spin or a counterclockwise spin, and that is an important concept in chemistry. And I can't show you the clocks that goes clockwise because I broke all my other clocks in the process of modifying this one, but I did order more and I think I now have it down so that I won't break them anymore. But all that tinkering aside, we're about to start a new study where we're looking at how physical and virtual manipulatives affect students' learning. Our hypothesis is that the way students move their hands affects their thinking about concepts in a very subtle way. For example, if you take this ball and stick model. To build the physical model, I make bonds by pushing the stick between the two spheres, and then I push them together. And then at some point I feel the resistance of that stick between them, so I can't move them, push them together any further. So the idea is that this pushing movement of my hands and feeling that resistance actually lines up with how bonds are formed. The positive nuclei attract not only their own electrons, but they also attract the electrons of the other atom. And that is why they move closer together. But now at some point they get so close that the positive nuclei repulse one another, and that is why you get a relatively consistent bond length across molecules. So the physical movement here with the pushing aligns with the concept of covalent bonding. By contrast, if I look at how I make bonds in a virtual bond stick model, the dragging motion when I build a bond is not at all in line with the concept of attractive and repulsive forces among the nuclei and the electrons. So in this case, we would hypothesize that the physical model is better for learning about this particular concept. However, there's another concept where we think the virtual manipulative would be better. Some elements like chlorine have a tendency of pulling electrons towards themselves, and that is related to their high electronegativity. So now when I'm in the virtual model, I'm dragging to make the bond. That is actually in line with the concept of electronegativity in polar bonds because the electrons are being pulled towards the more electronegative atom. By contrast, in the physical model, I would still have to push this, so that is actually counter to that concept that the electrons would be attracted towards the chlorine atom. So in this case, our hypothesis is that the virtual model would actually be better for learning about electronegativity in polar bonds. And we have a variety of these hypotheses for different kinds of visuals. And the backwards clocks were actually one of the missing pieces until we could go ahead and collect data. So I don't know if the experiment will confirm our hypotheses, but whatever we find, I will definitely keep you posted.